And now all these components in our network, they come with certain, profiles, right? Certain physical parameters that determine their performance, as well as their characteristics of which photons, which kinds of optical packets and profiles they can accept and what they do to them. So they're characterized by things like wavelengths and rates and bandwidths. Also for the detectors, right? What's the resolution by which we can detect these single photons? These detectors actually have a dead time where they need to kind of refresh before they detect another photon. There's efficiencies with these. There's rates for counts per second we can achieve. There's also loss on the fiber, right? That was one of the primary challenges with all of these systems is the fiber loss, and the fact that this source is producing pairs, but maybe not both of the photons actually reach Alice and Bob. So there's this parameter of link loss as well. So the point being, there are many parameters we have to take into account for this physical layer setup. They need to interoperate together. They need to perform and coordinate in the same kind of system. How do we design this? How do we align our optical components? How do we ensure the signal integrity that we expect based on these performance specs? And so that's where really the simulator comes into play. So simulation is critical here for setting up, running, and visualizing simulations of this link, right? We need to actually simulate the protocol logic that we need, not just the quantum distribution and the state evolution and all of that, but also the protocols and the communications that Alice and Bob need to communicate to each other, classical information. We need to model the noise on these components based on their performance specs. And at the back end, we actually need to actually accurately model these quantum photons at the single photon level at picosecond or nanosecond resolution, to actually simulate these quantum states as they travel through the fiber, as they pass through the beam splitter. What happens to that initial quantum state, that nice HV plus VH, that very simple ideal quantum state? How does it actually evolve in a realistic link like we presented? So having a simulator framework is very, very useful for design and for validation, and also for expected performance.